Hello, welcome back to FE Test Prep. Today we're going to do another statics problem. This is going to be one that is more centered around moments and forces. So last one we did example problem 1 was more about forces. We didn't really touch on moments. But since we're talking about the summation of the moments and the summation of the forces, this one's going to be a combination of forces and moments in order to solve for what we want. So let's get into it. This is our problem here. What we've got is, if you can believe it, this is a ladder. I know that this is side view, so just give me some credit here. So this is going to be a ladder leaned up against a wall. And if you know OSHA standards, it needs to be, oh shoot, I should probably know this. Anyways, we're going to move past that. It needs to be a certain amount out for a certain height. This is leaned up against the wall, and we've got a force, we've got a load on the ladder, 800 newtons at 7 meters up from the bottom, and the ladder is propped against the wall. It is stable. This is statics, right? So not moving. The bottom floor has a coefficient of friction of 0.4, and the side wall has a coefficient of friction of 0. So there's no friction on the wall, but there's friction on the floor, which is how the ladder is able to resist moving. So our goal is to find the F of C of X, which is the force at C in the X direction. The X direction is going to be horizontal plane. This is our Y direction. So how do we go about solving for F of C of X? The first thing you should ask yourself is, what are all of the forces at play? So let's draw a free body diagram. I've got a force this way. All right, we'll call this F of C of X. I've got a force this way, F of C of Y. I've got a force this way, this is my 800 newtons, and I've got a force this way, this is going to be F of A of Y. So I know that I've got 800 newtons down, so I've got to have a force resisting the opposite direction. So that's going to be my F of C of Y, because we've got friction here, right? So otherwise the ladder would slide. So I've got a force that's pushing up on the bottom, I've got a force that's pushing this way on the bottom from friction, and then obviously opposite of that, I've got a force that's pushing horizontally away from the wall at A. And I don't have any vertical force here, right? Because there's no friction at A. So this is the forces that I've got, and I need to find this guy. So how do I find this guy? Well, I'm going to want to do basically a summation of the forces, or excuse me, summation of the moments about C. Because I can ignore the forces at play here when I sum the moments about here, right? Because the moment with the forces at the location are 0, because there's no way that these forces could contribute to a moment about the C point on the ladder. But I know this 800 Newton force and this A force in the horizontal direction are both going to contribute to the moment. And if I can get this force at A, then I know opposite and opposing forces, the force at A has to be equal to the X force at C, just based on our free body diagram. So how do I get the force at A? We need, let me say X, so we'll say this equals 0 equals 800, right, 800 newtons times the distance, X, 800 newtons times X, which we need to get, right? So right hand rule, I'm going to call 800 newtons going down, curling this way, curling the ladder this way, coming out of the board. That's going to be positive. This is my F of FAY. That's going to want to curl the ladder this way. So I'm going to call that negative into the board at C minus this moment, which is going to be, F of A of Y times Y. Alright, so I started with the equation that I know is going to get me what I want. Right, this is where I want to go. I know the moment. If I can get the moment about C, I can solve for F of A of Y very easily. And then F of A of Y is going to equal F of C of X. So let's just write that as a premise. F of A of Y. This is actually F of A of X. Because it's in the X direction, folks. We wouldn't be talking about it otherwise. F of A of X equals F of C of X, right? Check, 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 check. Makes sense. Equal and opposite, guys. Newton's third law. Look it up. How do we get x and y? Let's start there. We're going to have to do a little trigonometry. Bear with me here. First, I'm going to make this smaller triangle. So we basically got a triangle set up like this. We've got two similar triangles split here. I know this distance is 7. I know this distance is 10. I know this is 70. So how do I figure out x here and y here? Well, I can figure out x here pretty easily, right? I'll say tangent of 70 equals opposite adjacent 7 over x. X in this case is going to equal 2.55. Just because, like, I know this, I can just do trigonometry in my head. Obviously, just kidding, I've got pre-prepared notes. So x is 2.55 here. How do I get the y? The y I can go, that's sine. Yep, so sine of 70 equals y. My x looks like y's. Y over 10. In this case, y is going to equal 9.4. So now I've got my x, I've got my y. I'm going to plug these in up here. We got boom boom, my triangle deal here. Alright, now I can solve for f of a of x, right? So let's say f of a of x equals 800 times x is going to be 2.55 divided by y, which is going to be 9.4, and that is going to give us 217 approximately newtons. And we know that f of a of x equals f of c of x, and so this is our answer based on our free body diagram. Boom, we solved it. Alright, just as a review for how we did this problem, first we said, let's draw the free body diagram because we need to know what the forces acting on this object are. And then we can look at how to solve for what we want. So we drew the forces. We had two forces at C. We had one force at A, right? You got A, B, C. And then we said, all right, how do I solve for f of c of x? 800 newtons of my x minus f a of x, right hand rule negative moment, and my y. And then we solved for x and y with a little trigonometry. Boom, boom. Sub those in, get f of a of x. F of a of x equals f of c of x, because we've only got two forces in the x direction, right? You could technically write this as sum of the forces in the x direction equals 0, equal f of a of x minus f of c of x, right? But that's basically this. These are the same. So this is a bit of an assumption, but so you've got some of the moments and some of the forces in this problem. So keep that in mind. And yeah, I thought it was an interesting problem. Hope you learned something, and looking forward to seeing you next one.